All right, welcome to 7.6, day 2. There's one review question. Let's go ahead and do that. It says evaluate this without a calculator. I'll come back in just a moment. We'll go over it. Make sure that you pause. Hopefully we got negative 20. Cosine of 0 is 1. So log base 10 of 1. 10 to what power gives you 1? That would be 0. And then 2 times ln of e to the 4th. Well, the ln and the e basically cancel each other out. 2 times 4 is 8. And then we have 14 log base 10 of 0.01. Well, 10 to what power gives you 0.01? That would be negative 2. And then negative 2 times 14 is going to be minus 28. And then tangent of pi over 4 is 1. And then it would be natural log. Well, natural log is log base e. E to what power gives you 1? That would be 0. And when you add them all together, you get negative 20. All right, our goal today, we want to write constraints and objective functions and maximize or minimize these functions through the use of linear programming. So if you don't already have one, it's a good idea that you go and get yourself a ruler. You are going to need a ruler to make this work. So either a ruler, well, most of you don't even have that, but on your page you could use your ID or whatever. It is really important because where these lines end up crossing and the way you have to scale these, sometimes it's hard to tell if you don't draw good straight lines. So, I mean, I know some of you are going to resist, but this is really what you got to do. You are about to take a test that contains computation word problems worth 6 points each, computation problems, and then word problems worth 10 points each. So we have two things going on here. We have computation problems, those could be x's, and then we have word problems. I'm going to make those y's. And what it's saying is that to maximize my function, to maximize here, I would want to do the following. I would want to say that z is going to equal 6 points times each word or computation problem plus 10 points times each word problem. That is the maximization function. And then once they've told you that main part, then they're going to give you some other pieces of information. You have 40 minutes to take the test. It says, and you may answer no more than 12 problems. Assuming you answer all the problems attempted correctly, how many of each type of problem must you answer to maximize your score? What is the maximum score? So they said that we have no more than 12 problems that we can answer. Well, that means then that x plus y has got to be less than or equal to 12. The next thing that they're saying is that we have what did it say up here? You have 40 minutes to take the test. So 40 minutes to take the test means we're going to have the following. So it's saying that you can do computation problems. Sorry, I'm trying to get my screen to fix. Computation problems in 2 minutes, and word problems take 4 minutes, and you have 40 total minutes. So 2 minutes for the computation, 40 minutes for the, 4 minutes. 4 minutes, and altogether you can't exceed 40 minutes. And then the last two are the same two that you always have. X has to be greater than or equal to 0, and y has to be greater than or equal to 0. So I go over to my picture. I want to create this thing. I'm going to start the same way I've been, and that would be by creating my x and y axis. You don't have to start here. You could start somewhere else, but this is my x and y, and I'm greater than, so I'm in the first quadrant. Then it says I got to graph these two. So one way of doing this is just to keep in mind how big the numbers are going to get as you graph. And if I graph these, they're in standard form, so I'm just going to graph them in standard form. If I make y 0, x will be 12. If I, in this first, not the maximization function, but the x plus y. If I make x 0, then y will be 12. So I know on my y's and my x's I have to go to at least 12. And then for the other two functions, if I make y 0, then 2x is equal to 40, so x is going to be 20. So I know at the most I have to get to 20. Looking at this, there are only 14 spots going up and down. So I'm just going to do everything by 2. So 2, 4, 6 here, 2, 4, 6 here. I'm just going to do that. That should make things as good as I can get them anyway. So now I'm going to do this first one. Both x and y will be 12 in this one. So this was 6, 8, 10, 12. Here's this one. And then 8, 10, 12. Here's this one. And like I said, you need something straight here to be able to draw your picture. So try to find something that you can use that is going to give you a straight line. So good as I can get that one. And then the second one, so let me change colors here. The second one, it's going to be the same idea. If I make x 0, then y will be 10. So I'm going to go over here, and here is 10. And if I make the y 0 in this one, then x will be 20. So I got to go over to 20. This was 12, 14, 16, 18, 20. So here is the second function. And I'm going to use something straight, like I said, and hopefully this works. I haven't really tried this, so got an actual wood ruler. Sort of working. Then I'm looking at this. It looks to me like it's crossing. Now I got to find the points for the polygon. That was what it said yesterday in the last lesson. Well, the points for the polygon would be right there. It would be down here. It would be over here. And then it would be at the place where they cross. And what it looks like to me is it's crossing at 4, 8. Now, how could we check that to make sure we have the right one? We'll take the answers 4, 8, plug them back into both of those big equations, and they should work out. So 4 plus 8 is equal to 12. That works. And then if I have 4 for x, that's 8 here, and 8 for y would be 32. 8 and 32 equals 40. Those both work. So it's telling me I have the right values. Now what I want to do is I want to list my values. So obviously I have 0, 0. I'm going to have this one, which was 10. So 0, 10. I'm going to have 4, 8. And I'm going to have 20, no, what was it? 12, sorry, 12, 0. And remember, the area that we are interested in for this one is this area right here. So it's all that area in there. So now what do we do? Well, now we have to use the maximization function, and we have to maximize each one of those points and see which one works out. So we have z1. Well, that one's going to be 6 times 0 plus 10 times 0. That's 0. So that's z1. z2, we're going to have 6 times 0 plus 10 times 10. That gives us 100. z3, that's going to be 6 times 4 plus 10 times 8. That's going to be 24, and 80, that's 104. And then the z4, that's going to be 6 times 12 plus 10 times 0. That makes this 72. So when I look at all of these, the one that is the largest is going to be here. So we're saying that this has a max score of 104, and that means you are required to do 4 composition and 8 word problems. That would maximize your score. You could get 104 out of that. All right, let's take a look at this next one. In this next one, it's saying just write the constraints in the objective function. They don't want you to solve this, so this is not a solving problem. The theater is presenting a program for students and their parents on drinking and driving. The proceeds will be donated to a local alcohol information center. Admission is $2 for parents and $1 for students. However, the situation has constraints. So, first of all, it says admission, parents. I'll make parents X and I will make students Y. And so the Z function here, the maximization function, is going to be 2x plus Y. Now, once I've got my maximization, I'm going to then try to find all the rest of these. So it says the constraints. The theater can hold no more than 150 people. So that means x plus y is going to be less than or equal to 150. And every 2 parents must bring at least 1 child. Now, this is kind of the one that's the tough one because it just seems like it's backwards from what it should be. But hopefully this makes sense. If you have 2 parents and they have to bring at least 1 child, well, then y has got to be greater than or equal to 1/2 of x. Now, why is that the case? Well, if you have 2 parents and they bring 1 child, well then y would be 1, x would be 2, and 1 is equal to or greater than or equal to 1. That works. But it says they can bring, or they must bring at least 1 student. That means they could bring more. So if we have 2 kids, then this is 2. If you have 2 parents, that's 1/2 of 2 is 1. 2 is greater than or equal to 1. If you bring 4 kids, then it's 4 is greater than or equal to 1. So I know that one seems a little weird sometimes, but that is the way that we would write this particular one. And then we have our normal constraints, one of them being that x has to be greater than 0, and the other one that y has to be greater than 0. And it said what they wanted you to do is just write these. So here are all of your functions. Here is the maximization function at the top, and these are the constraints down below. Hopefully that makes sense. That's going to be a lot of what this is just writing those constraints. Let's look at example 3. So example 3 says, on June 24th, just want to get this. On June 24th, the former Soviet Union blocked all land and water routes through East Germany to Berlin. A gigantic airlift was organized using American and British planes to bring food, clothing, and other supplies to the more than 2 million people in West Berlin. The cargo capacity was 30,000 cubic feet for an American plane and 20,000 cubic feet for a British plane. To break the Soviet blockade, the Western Allies had to maximize cargo, but were subject to the following restrictions. So, before I go any further, we should be able to right now write our z function. Our z function should equal 30,000, and we'll make the American planes x and the British planes y. So x, and then plus 20,000 y. There is our maximization. Now we need to come up with our restrictions here. It says no more than 44 planes could be used. So between the American planes and the British planes, well, those have to be less than or equal to 44. That would be the first one. Then it says the larger American planes required 16 personnel, excuse me, double that of the requirement for British planes. The total number of personnel available could not exceed 512. So that means 16x plus, they're saying the Americans were double the requirement for the British, so 8y, and altogether that could not exceed 512. Then it says the cost of an American flight was $9,000 and the cost of a British flight was $5,000, and total weekly costs could not exceed $300,000. So you have $9,000 plus 5,000 y, and it could not exceed $300,000. There are my three constraints, plus the normal three that I have. X has to be greater than 0, y has to be greater than 0. So we are in the first quadrant again. That's going to be the case with most of these. So I'm going to go down to my picture and I'm going to put in my X and Y. Alright, there's my X and Y, so I've killed off the bottom two. And now I'm going to have to graph all of these. And in order to graph them all, I'm going to have to see roughly what is the biggest value that I'm going to need here. And you would do that by just figuring out what each vertex is going to be. So I'm just going to do that up here. I'm going to start with the first equation. And the first equation, if I put in 0 for X, then my Y is going to be 44. And if I put in 0 for Y, then my X is going to be 44. So those would be the first two that I would have. Then the second two, I would end up having 16X and 8Y. Excuse me. So for 16X, that means if I put in 0 for Y, I'll do 0 for X, then 8 divided into 512 would give us 64. And if I do 0 for Y, then 16 divided into 512, that one I got to grab my calculator for because I don't know that one off the top of my head. So that's going to be 512 divided by 16. That's going to be 32. So I have 32, 0. And then I'm going to find a different color for this one. Maybe I'll do purple. Let's say this one. If I make X 0, then Y would be 60. And if I make Y 0, this one I believe comes out to be kind of an oddball one. If I make Y 0, then 9,000 into 300,000 ends up being 33 1/3. So there are all the points that I need to plot. I got to look at this thing now and figure out how am I going to make that work. And it looks like for 14 numbers here, I'm just going to go by 6s. So this would be 6, this would be 12, this would be 18, this would be 24, this would be 30, this is 36, this is 42, this is 48, this is 54, this is 60, this is 66, this is 72, and so on. Down here I'll do the same. This is 6, this is 12, this is 18, 24, 30, 36, 42, 48, 54, 60, 66, and 72. Now I'm going to graph these, and I'll just start with, I've got purple, so I'll start there. 0, 60, that would put me up here. And 33 1/3. So the midway point would be 33. So this would be just past the midway point. And that's why when you do these, you're going to need something with a straight edge to give yourself any chance of drawing this somewhat accurately. So let me try my best here. It's just hard to do on this thing. Alright, there's the first one. And now I'm going to go to, I'm going to do the red one next. So 0.44, well, 42 to 46, the midway point is going to be 45, so it's just below the midpoint. And like I said, these are tough. That's for that one. And then 44 over here, same idea. It's going to be just below the midpoint here. So hopefully we can get this one in. And then the last one, it said it was at 0.64. That one will be easy to find. And 32.0. So 32 is going to be just in front of this point. And 64 or 0.64, that one is going to be 63. So 64 is going to be just above the midpoint on this one. And we have our last one that we're going to draw here. So I'm looking at this thing, and here's the problem: is when you look at these, sometimes it's hard to tell. Super hard to tell. It looks to me like it's crossing somewhere right about here. And so then I have to start making a decision. What is this going to be? Well, it's 24, it looks like, across from the y-axis. And then it looks to me like it is at 20. But once again, if your picture is not good, that's going to make this kind of difficult. So I'm just kind of pointing out to you guys that you do need to pay attention to that. Our area will be everything right here. So that would be our area for what we're looking for. Now, to figure out whether that works or not, do what you did in the last problem. Take that point, plug it into each one of these equations up here, and make sure it works. 20, 24. If I put that in the first one, 20 plus 24 is 44. That's a good sign that I'm in the right place. So that's how you check them to make sure, because the graph is not always going to be super accurate for you. So you've got to pay attention to that. So now I need to do my z values. So z1. Looking at this, sorry, we have 0, 0 right here for those 2 points. So altogether I have this point right here, and that point right there. And because I have all those, I'm going to use all those. So 0, 0, let me just put these up here. 0, 0, that's one of the points. 0, 44 is another point. The next one was 20, 24. And the last one would be 0, 32, I believe, was the other one. No, 32, 0, sorry. So 32, 0. And now I'm going to test each one of those in the z function, starting with the first one, which is always usually the easiest. This is 30,000 times 0 plus 20,000 times 0. That gives you 0. Z1 is usually not the case, but if you're trying to minimize, that would be an option there. So don't just get hung up on the fact that you don't have to do that one. 30,000 times, this would be 0 plus 20,000 times 44. That would be in the number 2. That would give you 880,000. Then Z, that was 2, sorry, Z3, well, that's going to be 30,000 times 20 plus 20,000 times 24. That one is going to give you 1,080,000. And then Z4, well, that would be 30,000 times the x value here, which was 32, plus 20,000 times 0. This one gives you 288,000. So obviously it's this one right here that is maximizing. And so we would say that we would have 20 American planes, 20 American, and 24 British planes would give you a maximum volume, or what do they call this? Cargo capacity. Maximum, let's say it that way. Cargo capacity of 1,080,000 cubic feet. That would be how you would find that answer. So, maximizing. Hopefully this makes sense. If you got questions, ask your teacher. See you in the next lesson. Bye.